experiments on UV for highline webbings. So yeah, let's go straight into it. The experiments where we exposed a bunch of webbing at this location, Jungfraujoch. It's in Switzerland, not too far from here. It's quite high, so it has high UV exposure. It also has big variation of temperature over the year, which we in the, because like temperature affects so much webbing as well in this range, not as much as UV. And also, most interestingly for us, there was a weather station at the top, so we could get exact UV data from all the time of the experiment. What happened here? So we put 7 webbing types of polyester and polyamide, which represent the most common webbing used at the time this thing was started. So that was already 4 years ago. So 4 years ago, these frames were attached up there, and then some webbings were collected for the next 2 years, like in the first, after a week, after a month, after 3 months, after 6 months, after a year, after 2 years. Then they were brought to Seabird Consulting Labs in Vienna and tested there according to the ISA 41 webbing standard procedure. So with web block with big diameters, not something that you can buy or use on a highline. I mean, you could use it on a highline, but and then we will look at the results. But first, we can just look at these webbings. Here you can see the discoloration, and like for so bottom right is red tube, and it's very clear which webbing has been in the sun the most time. It's almost white. But before that, it's actually not so even worse. Like if you look at the blue one, which is Sonic. Yeah, for Sonic, it's really hard to tell. So, like the first thing we can take away from this is some do show discoloration, but not all of them. So, just looking at the color of a webbing is not enough to know its age. Also, one more thing we tested was like there was, so for each data point you here is actually 3 samples, and we take the average of these 3 values. And there was first measurement with webbing before any of the tests happened, and there was another measurement with other piece of webbing which had been stored in the dark, not exposed to the UV, just to see the difference after a bit over 2 years of just being stored. And we can see the difference, well, except for core 2, which lost quite like 3 kilonewtons. It looks quite a lot, but everything else, like some of them, the average was even higher than. So it's just error of just the number of samples, probably. So this to say that the age of webbing shouldn't be calculated just from the day you bought it. You can store it for a long period of time without being too worried about it. But then, if you put it to UV, then interesting start to happen. So, what do we have here? We have the forces that were the remaining breaking strength of the webbing for each type of webbing. So we have in blue colors, it's the webbings made of polyamide, and in orange red is the webbing made of polyester. And there's quite a difference between them. Is that the orange and red, they lose a lot of strength at the start, and then it plateaus, and the blue ones, it just keeps going down. So polyamide webbing keep losing strength over time. Polyester webbing do it less in our experiments, and as you can see here, we don't have that many data points. Like after a year, we have very little. But the most interesting also, and what's also interesting here is you can see this is not just the number of days exposed; it's the cumulative UV exposure. So if you just take the number of days, it doesn't. The curves don't match so well. Put the UV exposure instead of the number of days, then you have really like you really have nice curves. Otherwise, everything is shifted a bit, and so the data matches really that UV exposure is the important thing, not just the number of the time it was exposed. We're going to be doing more tests on that. So let's look a bit more into those strengths. So now we have everything, but it's all the same curves, but instead of having just the force, it's the force in percentage of the day zero. And here it's quite clear that all the polyester webbing behaving kind of the same way compared to the day zero, and all polyamide and nylon webbing behave kind of in the same way as well. So these curves are just regression curves calculated automatically by Google Sheets, except the X, which for those who don't know, it's from slideliner.de. This one lost much less strength compared to the other polyamide webbing, and it's not because it started with higher strength, it's not because it started with lower strength. It's like we don't really know why. The one option would be that it was made from different fibers of nylon, different type of fiber, different treatment. But yeah, this is really a bit inconclusive in that sense. So we have more tests coming as well. Yeah, and from before we go further into the recommendation, we must talk about the continuous tandem highline main and backup failure incident. So I don't know if you've heard about it. I think most people in the highline community have seen that, and it's quite recent. There we made an ISA report as well. You can read it. It's on the ISA website, and it was published on social media quite recently. But what happened basically is that there were two people in one highline, and one of them fell. It created a peak of tension, and then the main line broke. And as they were falling, the impact broke also the backup webbing. And these webbings were Moonwalk, which is a high. So not one of those we tested. It's with fibers of dyneema and other high-tech things, and it starts at 31 kilonewton. On a fall like this, the forces probably didn't go above 10 kilonewton, but the webbings had quite some lifetime. So the orange one, this was orange at some point. Had 500 days of exposure in the American Southwest, so it's a place where which has high values compared to, for example, Europe. And the main line had 300 days of exposure, around 300 days of exposure too. From this, they collected the other webbings that were in this setup. And some break tests, so they have all different histories, but you can see that the orange, it was all orange Moonwalk backup and all black Moonwalk, and you can see all the break test values, like 3 samples for each section, and some of them break as low as 9.24 kilonewton. This was, I think, it was not only a whale, but normal block. Quite concerning. So after seeing this, we revised our webbing lifetime recommendation. That's in the webbing standard, and also it should be included in the manufacturer's manual. But so polyamide and polyester that basically we had before, and this was kind of corroborated by the UV test. So these recommendations are only in terms of UV damage. If a webbing gets dropped into acid, then don't use it anymore. If a webbing is cut halfway through, don't use it anymore. But if you don't see any more damage, then just UV damage, then this is the lifetime recommendation of webbings. So 100 for webbing of type C, which is above 22 kilonewton for polyester, and polyester have this. But then what happens after this report is that we have removed all recommendation for our high-tech webbing because we cannot make a recommendation, we don't know. There's also one more thing that makes it hard to make a recommendation like this, is that this says 180 days of exposure, but as we've seen, it's not the number of days, it's really for in summer in Europe, you have much more UV than in winter in Europe, but also here is a map of the UV level in different countries. Here we're here in Switzerland, we're in the region with the lowest thing on the map. But places like southwest US has is like close to Mexico. It has a lot of higher values, which is double the amount of UV. And then places like Peru, Brazil, or also high mountains places, it gives a different number, different numbers. We are working on something to help people understand how much UV is in their countries, but it's also one of those projects where we need more help. And if people are motivated to do that, contact us. So right now, as early as yesterday evening, we were preparing webbings for a new round of tests. So we have high-tech webbings in this round of tests from different manufacturers, different kind of constructions of these webbings, different kind of fibers. To test as much as possible. So we have it's going to be over a year. It's going to be in a place which has not super high UV intensity. It's just on the roof right next to here. And we're going to be testing also other materials. So as I said, it's starting now. So we're going to be trying to set up the frames for these tests, and then all the samples are going to be brake tested as they are just in the building here where we have a brake test machine. There's probably room for more webbing if you have it needs to be, or other materials. So we are also testing a Dyneema 12 braid because it's used a lot now in highlining for connections, for extenders,
also climbing slings. Actually, I just talked to Top Rope that offers here their facility, and they will give us lots of different climbing slings to test as well.
Nice.
Most necessarily, I think also the Dyneema slings, which will be very interesting.
Yeah, and this is starting now, and hopefully in a year, if the safety event is the same time next year, then the results won't be in yet, but we'll have the results soon after. That's it for me. Thank you very much for listening. If you have any questions. Yes, there is questions.
Maybe step over here quickly. It's easier.
Thanks, Augustin. I have a few questions. The first one is you made the test by considering the parameter of cumulative exposure.
Yeah.
Are you planning to compare, for example, two webbings, two identical webbings with the same cumulative exposure, but one, for example, will be exposed two times longer than the other,
yeah,
2 times less?
Yeah.
So we're trying to do that by exposing like webbing for 6 months in winter versus 1 month in summer, and that all of those things it's in the plan.
Okay. Second point. You made the distinction in between polyester and polyamide, but you're surely aware that polyester is a polyester, and those are always the same material, but polyamide is a family of.
Yeah, that's probably why.
Difference, and for sure, it's like an oven spider. We are concerned. Maybe you've heard about the boom boom. The boom boom permarig.
Yeah, I've maybe heard of it. Yeah.
Really loud values, and this is for so far. We are concluding that it's clearly due to a quality of polyamide that is really strong when brand new, but it's decreasing faster than the other qualities, for example.
We have some boom boom in the test as well.
It is. This is something maybe you should only make the category polyester, but polyester and the different polyamides categories.
For the certification, you mean?
Yes, for the certification, even for you if you want to compare, because for example in between 6 and PS66, when brand new the webbings are looking the same and almost the same breaking strength, but it's not aging the same. It's like totally different materials in behavior.
Yeah, the one thing we have as an issue with that is that we need to rely on the manufacturer to tell us which fiber they're using, and the manufacturer needs to rely on their producers.
It is, yes. For us, it has been a long study to go back to that. We are able to nominate the quality of the polyamide, and let's just keep in mind that there are several different specific polyamides, and it's important to make the difference.
Yeah.
I guess it can make sense to have like certain polyamides being accepted for highline webbing and others not. So you say, okay, if you know PA66 is okay for highlines, but PA6 is not good, or PA12, I don't know what else is existing. I think it makes sense to look at the numbers, to ask manufacturers what is the nylon exactly they're using. You get the numbers and say, okay, this seems to work, so this is fine, and others are just not accepted yet in the standard. So if you bring out like a new nylon with like another polyamide which is not proven to be strong, you need to make the tests and you need to get the UV study done to show that this is actually like lasting for a long time.
It is, for example, the boom boom. I would not say that it's a dangerous webbing, but for long-term permarig, it can become dangerous. So you are offering some, suggesting some number of days of exposure, and I think this number should be different, just depending on the webbing. That's all.
Yeah.
Last point we will discuss separately.
I have a follow-up to this. If we are doing this, I have a follow-up to this. If we conduct this new series of studies and we know the exact amount of radiation that has hit the fibers, can we maybe at the same period of time do some tests with artificial UV radiation to maybe conduct this kind of tests in labs in the future? So manufacturers have the ability to just say we need this kind of light source to test in the lab, in a way, in much quicker iterations.
So yeah, that's really related to the question that Florent was asking at the start. That if you have the same UV exposure, but in the so that's why we're testing this with summer versus winter. Then UV labs are a bit expensive.
Also, they're all different. That's another problem. There's different machines and they have different lamps, and
yeah,
you can do it yourself. But again, there's many different qualities of lamps, like wavelengths that you can expose it to. So there's huge variation.
Sure,
there.
but maybe we can talk about this in here and just maybe find one kind of radiation source that we can agree on.
How does that relate to the real life? That's in the next.
Yes,
that's part of
Sure.
the experiment. Is we check how much it is UV, then we can check in a UV lab.
Yeah.
And that's much faster to do, so we don't need to plan it a year in advance.
And this has been done in the climbing industry, or tried in the climbing industries in the last 20, 30 years, and they haven't managed. It's not in any standard. It's not included in anything. That already tells us a little bit something about how complicated this is. So, I mean, we're definitely going to try these. We have been in contact with labs since years, but we just never managed to get affordable tests going. That was kind of the main challenge. But yeah, you can do them yourselves. We know that. And do these UV lamps, UV testing facilities.
And we are doing some UV testing, just like you in the same.
Yeah.
we are planning to make also some long-term UV tests, some accelerated UV tests on UV lamps. So maybe yes, we can keep in touch.
Good.
We have one question here. Whether it will make a big difference in what was the name? Whether it would be a difference in tension lines versus just lines on frames.
Yes.
Because the webbing will be more stretched out, maybe the core will be more exposed.
So we want to have a part of the frames that we're using up there which have some tension.
Okay, there's one last question from Robin online. Last question of the day. Robin, go ahead. Robin, are you still here? Can you hear us? Your microphone is... Yeah. Wait.
I had a question concerning the... you talked about rain also, and from a chemistry point of view, if you want to break polymers, you need UV and you need water to break bonds between the polymers. So did you stop that, and is it taken in account also?
We are not yet putting things on. Like if you add more factors to it, it just becomes. Okay, let's say that this way. For the experiments that we've done already, trying to take into account the temperature, the humidity, all these other factors, it didn't make a difference. Didn't make curves fit better to a regression or so. I think UV is really the main cause of damage. The rain, it does have an effect. Humidity has an effect when the webbing is tension. So that's actually like if you have tension plus rain, and then the cycles of then that might damage cycle of humidity with tension. If you have no tension, it doesn't do anything. I think for webbings. But yeah. So many parameters that we could test. We are trying to keep the study manageable, but maybe we can do something where you just webbing in tension, put water on it, and then you dry it, and you put water on it, and you do that 700 times.
Right, this machine with the sleeping loading, just a sprayer.
Wait, you have to turn on the microphone quickly. There.
Sorry, you have to
accelerate the process than only UV and intention, like you said.
Sorry, say again. Can you repeat? We have microphone problems with too many here.
Yeah, my point was UV plus water is the perfect equilibrium to break polymers and intention, as you said. So, yeah, I think this could be really interesting to see if the successive UV and rain intention could really accelerate this process.
Okay, something that against this is actually that the most extreme reductions in breaking strength we've seen mostly from South America, so from central Brazil near the equator. They have high humidity, but they, for example, don't have rain. So yeah, this makes it super complicated, the whole issue.
I mean, I guess like rain is not the problem because during rain it's not sunny usually. In most cases, so it's the problem like in the morning, I guess. It's like there's humidity on the line, everything is soaked, the first sun is coming on, and then each day the line is like full sun exposure, drying off for half an hour. So we have half an hour of like wet webbing with like direct light on. I think that's the issue, or like rain and afterwards sun again. And I think that's like in Brazil more the case. If there's a thunderstorm coming, it's clearing up again and there's like sun again on it. So I think it's much more often happening that the line is drying out in sun conditions than here in Europe, where it's like either like a day for the whole day. So it's like the line is soaking wet for 3 weeks, but almost no UV on it. So maybe that's actually the point.
So maybe we can leave that for when we do actually test in the weathering lab with UV lamps and controllable humidity. It's
Yeah.
not possible. It's beyond what we can do at the moment, I think. But that
Okay.
concludes the presentation.